Welcome to the third tutorial in the SIDD online tutorial series. In the first few tutorials we have walked through what the model is really for, how to load the model up onto a new computer, and how to use the model in order to generate simulated output. In this tutorial we'll be focusing explicitly on the prime reason why the model was produced, to explore the effects of alternative policy counterfactuals. Now, because this tutorial is actually quite a bit longer than the preceding tutorials in this series, it's broken up into manageable bite-sized pieces. In this piece, we'll really just be defining the subject for analysis. In the second, we'll be considering how to alter the model code. In the third, we'll be using the model to generate data for policy counterfactuals, and in the fourth we'll be analyzing those data. So let's define the subject for analysis. Now this can be a sort of overwhelming subject, at least when you first come to start using models of this sort. And one thing that I guess I've found useful as a tool for trying to work out whether a job is worth doing or not is to consider this idea of if. If a subject satisfies both the conditions that I note here, then it might be viable for analysis. The first condition is that it should be interesting. This might seem obvious, but a lot of people get cracking on things that they find personally interesting without considering whether the literature will find it interesting, and that just is a recipe for disaster. So it's strongly recommended that before even beginning analysis, you should consider whether the subject that you're about to embark on fits into the existing literature, whether it's already been looked at by somebody else. Someone will have addressed some aspect of the work, there's little doubt about that, but your work should fit into the existing literature. If it doesn't, then you're wasting your time. Indeed, one of the key criteria to trying to get your papers published in really top-grade journals is to embed the analysis really well into the existing literature. If you haven't done that, you can forget about top-grade journals. You're at least looking at a second tier, if not a lower rung journal. So it's got to be interesting, not from it's nice if it's interesting from a personal perspective, but particularly from the perspective of the literature. Secondly, it has to be feasible, and this can be really tough to work out whether it's the case for a particular study, especially when you first get started. Nevertheless, one useful tool that I sort of try to bear in the back of my mind is that if I think that after all the wrinkles of the analysis have been worked out and the data is sort of in hand and all of that sort of thing, once I've got all of those sort of nitty-gritty problems worked out, which often take a lot of time to sort out themselves, but once all of those things are done, in order for someone to replicate my analysis, in order for someone to just follow a cookbook recipe through what I've done, it shouldn't take any more than 3 weeks from start to stop. If it takes more than 3 weeks, it's likely that the whole job that you're doing is likely to take very much more than a couple of months, and then you're really starting to look at something that really is becoming unmanageable from the perspective of a publishable paper. So interesting, feasible, absolutely crucial. So what are we looking at here? Well, the subject that we're looking at here is to consider the importance of behavioral endogeneity for policy projections. Now, the motivation, the fundamental motivation for this study, the impetus for this study was really a presentation that I needed to make at the 6th World Congress of the International Microsimulation Association, held in Turin in June of 2017. The motivation for the study was really repeated conversations that I had with people in this field, the dynamic microsimulation literature, where I tried to explain what kind of work we were doing in the area at the National Institute. And in that regard, basically I'd say, well, you know, it's a standard dynamic microsimulation model with the life cycle model at its heart, so that savings, labor supply, and investment decisions are all based on optimizing decision making. And sometimes you would see people think, oh, well, what does that mean? And normally my response to that question would be, well, the whole idea of putting the life cycle theory at the heart of this sort of model is to get a coherent basis for generating the effects of policy counterfactuals, and that's really what this model is designed and built for. On the other end of the scale, you know, trying to build in the life cycle model is a costly exercise. It takes time to develop, time to parameterize, and it implies a very substantive computational burden, and all of these things are costly. And then, you know, the immediate response is, well, are these costs worth paying? Is this coherent structure that you refer to, does it really make a big difference? And there, the response has been sort of difficult to provide in unequivocal terms, primarily because the effects of allowing for behavioral endogeneity are context specific and therefore opaque. So this is really my considered attempt to try and provide an answer to this question, you know, what practical bearing does behavioral endogeneity within a dynamic microsimulation context actually make? So to address this issue, I consider two key questions. First of all, how important are impact effects of policy change relative to associated incentive effects? And here this question is really designed to provide a sense of the overall importance of behavior responses when analyzing policy change. And secondly, related to that first question, to what extent can the overall influence of behavior responses to policy change be approximated by labor supply responses alone? And here, this second question is really designed to indicate the practical importance of analytically convenient modeling assumptions. It's 2017 today. In 2013, Lee and O'Donoghue published in the Journal of the International Microsimulation Association a review of dynamic microsimulation models, in which they say, you know, structure is starting to be included in these models, but it's early days. Basically, something like 13 of the models that they identify out of over 60 included some structure. They note that to date, there's very little evidence that the life cycle model is really being built into such models, and that the vast majority of cases where structure is being built in is in the form of labor supply, either as hours worked or as a retirement decision. So really the second question is designed to consider to what extent that beginning where people are building in labor supply structure into dynamic microsimulation models is really getting you know, how much of the overall, you know, labor response will that sort of stylization capture. Now, I should note that it's useful to focus explicitly on labor supply, because by doing so you can omit forward-looking behavior, and by omitting forward-looking behavior you can sort of substantively reduce your computational burden. So So these questions are answered with reference to 2 policy counterfactuals and the sensitivity of the effects of those counterfactuals with respect to 3 alternative behavioral assumptions. The 2 policy counterfactuals are a rise in all rates of income tax by 10 percentage points and a fall of the value of the state retirement benefits by 20%. Both policies are applied from 2016 and are assumed to be unanticipated prior to that year. These are sort of standard policy counterfactuals. They're interesting because they imply very different incentive effects, and so for the current context, they present interesting variation. And they're really quite large, so you expect, you know, reasonably sizable behavioral responses in response to them. The behavioral alternatives that are assumed. The first is a functional description of behavior that under the base policy environment that remains unaltered under the counterfactual policy environment. So basically this behavioral alternative is assumed to capture the kind of econometric reduced form approach that has been popular in the classical literature. The idea is that you've got a labour supply description, for example, that you've taken to the data on some historical time series. It's a reduced form. You haven't based it on any kind of structure at all. And then you assume that functional description of behavior remains invariant as you change your policy context. So basically it's capturing that. Jumping over to the third alternative, this is the case in which savings and labour supply both respond optimally to the policy counterfactual. This is kind of your standard life cycle approach, structural approach to modelling. And the second is an intermediate that allows labour supply responses to the policy counterfactual, but assumes that savings behaviour remains functionally invariant to the policy context. So 2 policy counterfactuals, 3 behaviour alternatives, 6 combinations in total. In this tutorial series, we'll just be looking at 1 combination. I should note that in the materials to this tutorial, you can find the paper that was written after this analysis was undertaken, so you can see what was generated. And you should indeed be able to replicate the results that are reported there in the comfort of your own home. Anyway, that's it for the introduction. Let's come back in the second part of this tutorial.